So, hi everyone. Now we have the GraphRAG system that asks back intelligent probing with better contextual answers by Rajesh Sridhar and Vivek Singh. And over to you guys.
All right, thank you so much. Hello, everyone. I'm going to quickly share my screen, and that should be available for everyone. So, thanks for joining our session to begin with. I know it's a pretty tight schedule, and if there's so many agenda item, thanks for taking out time and joining us to begin with. Let me ask you this question, and maybe you already had this experience as of now. When you interact with ChatGPT, Gemini, any other system, and you asked a question and the system came up with an answer, and we're like, no, 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 I was not even talking about this. This was something else altogether. Have you had that feeling? This is exactly the problem which we are trying to solve here. Now, our approach has been utilizing GraphRAG and doing something with it, where if user doesn't ask a question and does not have some essential detail to answer, we want to collect that. To do that specifically, we need an approach. But before I go in that, I'm a fan of Harry Potter to begin with. If you guys are a fan of Harry Potter, just let us know in the space. But if you have seen all the movies or read the book, there is a room which is called Room of Requirement. And one of the quote from from that whole scene is basically, if you have to ask, you will never know. And if you know, you need only ask. That's such a twisted word, which at the first glance doesn't make sense. But sometimes I feel that's how we leave our user when they're interacting with our chat and systems. Like, if you don't know how to ask, our system don't know how to answer. That's what we give the feeling to our customers and users. And this is exactly what we want to address. So let me ask you this question, and please respond to us in the chat in the session if you have done some of this. Have you created a RAG application from scratch successfully? Classic, naive, graph, whatever. Have you created it? Please respond to us in the chat space. And if you have created it, have you done both, which is naive and GraphRAG? If yes, please let us know in the space. And the last one, when you have created, how many of that has gone from proof of concept to a production where people are utilizing and they have an opportunity to tell you, hey, this works, this doesn't work. Maybe this is how I can bring things together. Please let us know if you have done that. And the reason I'm asking this question is because it's essential when we are looking at something to solve. Yes, proof of concept, awesome, worked, amazing. But then when you go to production, there are so many challenges. And these challenges actually just go and explode when you want to create a framework for your organization, for an enterprise. With that said, let me introduce both of us, Raj and me. Raj, over to you. Introduce yourself, and then I'll go next.
Yeah, thanks, Vivek. So, hey guys, I'm Rajesh Sridhar. I am part of Cisco. So we work in the CX organization in Cisco, and I particularly work in the proof of concepts group where we use AI/ML technologies and we build proof of concepts that are typically used by engineering groups and customer support groups. Over to you, Vivek.
Thank you so much. Thanks, Raj. And I see a lot of responses coming in the chat. Thank you for doing it. That makes us feel that we are connected with you. Otherwise, we'll be just talking to a screen. So please continue doing that. So my name is Vivek. I'm a senior technical leader in the customer experience within Cisco. And as the name says, the customer experience, we deal with customer. We figure out the day-to-day technical challenges and the work which they do. And how do we create a system which helps them? That's our goal. That's what we deal with. Now, part of the agenda, we are going to talk about RAG and the problem which we are trying to solve. How do we handle ambiguity? How does knowledge graph fits in? How do you enrich the context? And not just talking point, there will be a live demo and how we are handling this and we are solving it. And obviously, there will be takeaways for you. So you would be able to trying to build your system and go live with it. With that said, I know people here on the call, most of them may know RAG already, but this is just a quick glance of it, right? So RAG in general can be divided. Again, I'm talking very basic, classic naive RAG. Can be divided into two pieces. Ingestion, you take various kind of unstructured documents, split into chunks, embed it with your embedding models, and store in some sort of vector database. That's part of the ingestion. The second part is the retrieval, where a question comes, you go to that vector data store, you do the similarity search, you get the content or the context from which you would be able to generate the answer, you put in the prompt, and then finally LLM helps you to generate the answer. I know people know this, so I'm rushing through it. Hopefully this gives a quick glance of what we say when we say it's RAG. With that said, let me talk about some problems which we have dealt while going production. And I think it's very essential because then you would be able to connect with how we are solving and why we are solving. So the whole structure is divided into three pieces. First, the query. Second, what they are looking. And third, the challenge. So if you look at the question from Cisco networking domain, a customer has bought a product called Switch from us. They are asking about, hey, how do I upgrade? Now, this question by default is not very clear, right? It doesn't talk about from which version to what version, what details need to be provided. And if you go and implement a classic naive RAG, where you have ingested many documents from various versions, there are high chances that there are overlapping information between them. And if you just go with a vector similarity search, you'll get information and try to generate an answer, which might not even what customer is looking, because customer never told us what version they are working with. The second type of problem is when you are providing steps to our customer, these steps has to be complete. If the certain details has 10 step, 2 step, 15 step, you want to provide those complete steps. You don't want to leave them hanging in between. The third type of problem is when you schedule a meeting, right? This is another user query. When customers say, I want to schedule a meeting, it doesn't tell me which device they are scheduling from which app they are scheduling from. It's an incomplete user query, which means either I give so many variation of the answer or give a very specific answer, just assuming what customer is asking for. And the last one is if customer is asking, hey, give me maybe some information from logline, which is available in this unstructured document as an image. Now, if you take that image and don't do anything with it, you would not be able to give the answer. So you need to get the context from the image, then only you will be able to provide this answer. Now, so this is not a full list of problems, some problem on what we deal with when we go in production. But now let's multiply this when you are building a framework which accommodate across your company for various use cases. This will multiply. So when you are thinking about, okay, what should I do? It's not just about one use case. You solve one problem today, but you have to think about all the problems which are going to come and design your architecture accordingly. So let's take a scenario. We'll take you through the journey of this scenario and how we are handling and how we are manipulating our system. So a question comes, which is WebEx is slow. I have no idea what this cuts. Even as a human, I don't know what does this mean, right? Forget about the AI. So you have to have more context. So because it could be slow of starting meeting, slow to join a meeting. When customer is sharing a screen on the meeting, maybe that's slow. Or there's a delay in the audio video. There's a lip sync problem. Somebody said something, but the audio came later, or vice versa. So problem could be anything. So we are going to deal with this problem and how we are going to handle that. That will be the whole flow. So when you get this problem, how do you handle this? You got a WebEx is slow. Either your option is you take the question and you blast that question with what we call context enrichment, where you automatically change the question. Say WebEx is slow for meeting, join meeting, and audio, video, and all of that, which means you're going to overwhelm your user with answer. And obviously, nobody wants to do that, right? You want your user to be engaged. They feel they are connected and they get the answer. So context enrichment, if you have to do it, how do you do it intelligently? That's what we're going to cover. The other part is when we are providing the answer, we are going to ask a clarifying question. How exactly you're going to generate those clarifying questions? Because you need to understand the domain from which that question came in, and then generate a follow-up question to the user. And that's where we're going to touch on the probing side of it. But you don't want to continuously probe either a generic question or probe so many times customers like, I don't care, right? Think about when you are on a call center call and they're just asking a question. it's exactly the feeling which customer will get. So how do we do effectively and implement it? So I'm going to leave you with this 3 question when you're thinking about how do you generate or how do you build a clarification engine for your system. Which knowledge or what all knowledge in your enterprise you're going to use to generate a clarifying question. Second, when you decided what documents you're going to use, what part of that is going to help you to generate the question. And third, when do you decide to stop? When do you decide I'm not going to ask any follow-up question? And don't worry, we are going to answer these questions to you. It's not just for you, but it's about think how you're going to do it. With that, I'm going to hand it over to Raj to actually show how we are implementing today and how effectively that is working. Raj, over to you.
Thanks, Vivek. So let me share my screen. Just a minute.
While Raj is looking into it, if you have any thoughts, please do share in the chat space if you have done something similar. We would love to know and connect with you. So please do share your learning or your approach if you have done something similar.
Yeah, so let me share my screen. So let's talk about before we go and try to solve this. We understood one thing, right? That we need to build a clarification engine because the customer's query is going to be vague. So let's try to go through a quiz first. Try to understand how do we solve this. What is the right way? Should we use top K to get what the customer wants? Is it the right strategy? What are the other ways by which I can get some context that can be used to build a clarifying question? So let's go with each one of them step by step. Let's start with the top K. Now, this is a big problem because when you search for top K context, there is a possibility that what the user is actually intending, that is in K plus one context. So you're always going to run into that problem. The biggest problem is what is the right value of K that you should select when you are selecting that top K, right? So you can start with 10. You can probably, let's say that when you pick those 10 context to generate a clarifying question, those 10 context was not enough. Now, do you do something recursive, go and search another 20 context, and how long will you do it, right? And another thing is, remember, you are using all those contexts to generate one clarifying question. Is it even worth it? You're wasting a lot of tokens, right? So here's the problem. So you search top K results, but the actual intent that the customer or the user had is outside of your top K. What is the other way of doing that? We all are experts in RAG. I saw in the chat that people have mentioned that a lot of them have built use naive RAG. So I am pretty sure you guys are aware of metadata tagging, right? So what is the problem with metadata? Let's say I have 10 documents, right? And we take the same problem that we are trying to solve, where the customer has asked a question like, WebEx is slow. Now I can tag all those 10 documents with WebEx, right? I can even tag those documents with slow. But typically, when you do metadata tagging, you typically use named entities, right? So let's assume you still use slow to tag. Now, when you tag those 10 documents with WebEx and slow, let's say you find out 5 of those documents where WebEx and slow is there. Now, to generate clarifying question, you need to look into those 5 documents and feed it to an LLM, generate a clarifying question. Again, you're wasting a lot of tokens from those 5 documents to generate one clarifying question, right? This is also not scalable. So how do we do that? So before that, let's take a quiz and let's try to see what was the problem with using top K. Why was the top K method not reliable? Is it because it uses too many tokens, or is it because there could be a possible that we did not fetch the right context? Or is it because the vector databases are slow? I'm pretty sure you guys have already guessed it. The answer is B, because again, we are ending up with that K plus one problem, right? So let's try to understand. So we tried top K. This did not work. We tried metadata. Metadata tagging was better, but it missed one key functionality, which is when I look at the documents where WebEx and slow is tagged, I don't know what feature of WebEx are those documents talking about. There is a need for the relationships between WebEx and slow. If I can get that relationship from those documents, probably I don't need to look at those 5 documents. I can go directly to one document and generate clarifying questions, right? So the solution is we use knowledge graph as our agent's word model based on all the documents we have ingested, right? So let's do a dry run and try to understand how do we build this system, right? So what is the advantage of using knowledge graph, right? So rather than searching all those 10 documents, going inside those chunks and scraping them, sending it to an LLM, asking an LLM that, hey, look into this chunk, tell me how many different possibilities you see with WebEx and slow. And I do it for 10 documents, right? But with your knowledge graph, you will have explicit relationships, so you don't even need to go to the document. So it solves that top K problem where you can directly look at the entities and relationships, and you can figure out which path to go in the knowledge graph. Also, it will, because you are looking at those entities and relationships, you don't need to use the chunk data of that document, so you will be saving in the tokens as well. So let's look into this example, right? So you can see that we have when we talk about WebEx, there are 3 different parts that it is diverging in this. So from this, I can easily understand that I which part I need to go to ask a clarifying question. I don't even need to go to the layer 2 of it. What I need to do is I can directly go to the first layer. I can see that there is something which is talking about meeting joining time. It is talking about laggy screen share. It is talking about poor audio video quality. So before I even go and look into the actual documents, I use the first layer and ask clarifying question. So that is the advantage that you can get with a knowledge graph. So now let's whatever we have learned till now, let's try to use that knowledge and try to design our system, right? So let's say we have a detective which basically looks into the user query and tries to figure out whether that user query is vague or not. Let's say the user query is not vague. That's a very simple use case for us. We directly go to the answer agent or whatever we want to call it and give high fidelity answer. But let's say we get into a situation where we figure out that the user query is vague. Now we look into the knowledge graph and we try to see how many different variations of that question are there. And then we use something called as an interviewer or a probing agent to ask clarifying questions. Now, the user might give you the clarity when you ask the clarifying question, and then you use that to finally give the right answer. So on the right hand side, you see a Langgraph implementation of what I just discussed. So how it will work here is your supervisor will be your detective. So when the user is basically asking a question, the supervisor will basically go and talk to the retrieval agent, which could be a RAG agent or a GraphRAG agent, however you want to define it. That will give you back all the entities and relationships, and based on that the supervisor can make a decision whether there are like too many different paths in that knowledge graph or too many variations there. And if it decides about that, it will use that it will decide that, okay, I need to probably send this to the probing agent. So then the probing agent will use that information and generate probing questions. Now let's say the user gives the answer here, and once that is given, this time the supervisor detects that it has a more directed query now. Then again, from this, it can perform another set of retrieval, and this time it sees that there are not too many paths in the knowledge graph. It is very straightforward. then it can directly send those chunks to the, like if you have used GraphRAG, you will understand what I'm saying. So then you use those chunks, send it to the answer agent, and you get high fidelity answers. Okay. So now how this really works, right? So in this example, your supervisor was the detective and the strategist. Supervisor looked at your query and figured out whether the query was vague or not. And it also looked into the knowledge graph, whatever was retrieved by the retrieval agent, and figured out whether there were different paths. For example, in this, you can see that the user is talking about slowness, and we see that it is talking about WebEx has different paths in the knowledge graph. And there we see there is a feature called meeting, where there is a functionality called joining a meeting. There could be slowness there, or the slowness could be tagged to screen sharing, or the slowness could be because of some latency in audio video. So this is where your strategist or your supervisor sees, and it can decide that before I jump into this path or that path, I can use the first layer here and start asking clarifying questions. Okay. So in this example, let's say the interviewer or the supervisor goes back and asks these questions. To help you with WebEx, what part of WebEx is slow? Now you can see that it is asking exactly those points in the where the deviation started happening in the knowledge graph. Joining a meeting, sharing your screen, or your video quality. Now let's say that your user mentions that he is facing a problem with joining a meeting. That makes life easier for us. Now, what we do here is we know that the user has mentioned that he was facing a problem with joining a meeting. So we directly go and traverse this knowledge graph in this path, go to the right chunk and give him the right answer. Okay. So let me see if I can share, if I can give a demo here quickly. So stop sharing. Let me share. Just a minute. So I hope you guys can see my screen. So here I took another example where I asked a question like schedule a meeting. Now it is another vague question, right? When I say schedule a meeting, what platform I am using? Am I using WebEx? Am I using Outlook? Am I using Microsoft Teams? Even what kind of device I'm using. Am I trying to join it from some room device, or I am using some kind of a desktop device, or I am trying to use a mobile, right? So this is a vague question, and this is what our system generated. It asked what application or platform we are using, and it also asked you what devices are you using, right? Let's say I give an answer saying that, hey, I'm going to schedule this meeting from WebEx app, but I did not answer other questions. Now, what is happening here is the supervisor gave you an answer to schedule a meeting on desktop. It gave you an image, but it also gave you an answer for mobile. Now this is very simple because in our knowledge graph we only had two different modes from WebEx app. One was from computer and one was from mobile. So it was very simple. But this could have been much more difficult because if there are, let's say, 8 or 9 parts, right? So let me go back to our deck again. So let's see. So now we try to solve this problem, but then there is another question that comes in the mind is we deployed this system in the production. What are we what are the lessons that we have learned, right? So first thing, whatever we discussed will work really good for you if your knowledge graph is perfect. Now, if your knowledge graph is wrong, you will not be able to create those hypotheses or different paths or even ask right clarifying questions. So make sure that your knowledge graph is right. The second thing is when to ask a question, right? So I can see, let's say in the knowledge graph, I can see there are like 8 or 9 different paths for that particular user query. Now, should I ask 8 or 9 questions to the user? The user will not like it, right? So you need to draw that balance. How do you do that? You can create some kind of bias or classifier where you put some weightage on certain types of things and ask questions. The third thing here is, I think everybody loves evaluation, right? So that's the way how you look at your RAG system. There are frameworks like RAGAS and all those things that you use today to basically, certify your RAG system. But here, this is not enough because we introduced another layer of abstraction here. So we need to also measure the dialogue efficiency of this system. So are we asking the right question? And how many times are we asking? Let's say, so based on our experience, I can tell you that when you are asking, like, so the probing attempt that I showed you, let's say we try to probe 2 3 times to the customer. I'm telling you, if you try to probe at the third time, most of the time the customer is gonna close that chat and go away. Nobody likes to be asked too many questions because he's coming here to solve his problem. So we also need to measure the dialogue efficiency. When I asked two questions, did the customer like it? When I asked one question, did the customer like it? And did I ask the right question? Or why did I have to ask second time probing? What was missing in the first time probing? I could have probably merged that in the first attempt, right? So that's where you need to measure dialogue efficiency also. And with all of this, we were able to deploy a production grade rack system at Cisco, which is on a day-to-day basis is solving customer cases. Customer is coming with a query. A lot of the times, customers are like us, humans, they're asking vague questions. And this agent is going there and clarifying that with the customer based on the knowledge graph of the documents that we have ingested. And once that clarification is done, is going and giving right answer and even troubleshooting customer's problem and solving cases. Okay. So, okay, what is the key takeaway from today? First, when the prompt engineering came in the picture, there was zero shot prompting, and now there is no. Now we do a lot of complex prompting. Similarly, using that same analogy, you need to move your zero shot RAG solution to a clarification loop. Now, instead of directly going and answering to the customer, you need to add some reasoning ability to your system, and that's where knowledge graph comes in the picture. You can use that knowledge graph and build your own reasoning engine. Also, you need to make sure that when you're using that knowledge graph and asking questions, two things are important. How many questions should you ask to the customer? And when you should ask the customer, right? Not all the queries are vague, right? You need to make a decision when the customer is asking a question, whether that query is vague. And that's where you basically go and look at the knowledge graph and try to ask that question. Now, you need to understand once you have done everything like that, the next thing comes is whether your system is working fine or not. Now, this is where the evaluation comes in the picture. You define, for example, we talked about dialogue efficiency. You use that to evaluate your dialogue and see whether you are performing well. If the customer, if this mechanism is going, you are getting sometimes. So, for example, in our use case, we have seen that asking one question was good. Sometimes in some other use cases, we have seen asking two probing questions was also okay. So it all depends on use case to use case. So that's where the dialogue efficiency is important. So with that, I'd like to conclude our session. I think it's just 1 minute left. I know we didn't have time to clarify a lot of your questions. I see a lot of the questions, and my colleague is already trying to answer some of them. But if you guys have questions, feel free to reach out to us in LinkedIn. We'll be glad to answer your query.
Awesome. Thank you, Raj, for such a detail. Guys, please do take the snapshot of this QR code, connect with us on the LinkedIn. And obviously, our LinkedIn profile is also available on the agenda. And I love this group who joined us because there were so many questions, which means you were engaged with us. Thank you so much.